Hello, how are you? This is AP Statistics. This is Wednesday, April 8th. Let's review where we're at. Uh, Number one, the grading. Still getting some confusion, which is understanding of grading. What I am doing right now, I am doing your assignments for the week. At the end of the week, I look and see through the email system if you've done them. If you've done them, I give you a P2. If you've did like one of them and there were three of them, I give you a P1. And if I haven't heard from you at all, I give you a P0. So that would, I guess, from what the feedback I'm getting from people, it's not giving you a cum grade, but I don't know. That's what I was told. So I would look at individual assignments. As long as you are keeping in touch with me and you're following the videos, I'm putting the assignment on the videos, and they are usually just a couple of problems based on what I did with the lesson, which is straightforward. You will be fine. And as we've found, I'm doing this kind of on a week by week basis now. And on Monday morning, I kind of grade and see who got the assignments in. But if you didn't get them in, just get them in Monday or Tuesday, and I will change the grade. I have no problem with that. That's what I was told by administration. Keep in touch with you and, keep some content, but not to go too deep in this new mode of learning we have. Also, AP, I keep reminding you this, the exam deal is getting close. I know there are resources for you, but if you are taking the exam, remember, my hint to you, first of all, we're not going to get through what you would need to take it. Unless you're taking the quick option. I'm not sure what's on that. Maybe that may be the case with that. But if you are going for the full-length version, I can't stress to you enough those free response questions on the AP Statistics website with answers, with detailed answers. And look at the last 2 or 3 years. You will recognize some of the questions because we had them from earlier content areas we had in class. That to me is the best way to study. And then maybe take some of those multiple choice questions that I had given you on earlier tests and look over those too. Plus, I know that they're giving other resources, other instruction and so forth. So all those things will work. But I just want you to be diligent about the fact that what we're doing here, these little short lessons aren't going to get it done. This is more for people in the class. Those of you who are taking the test obviously need this too, but even more so the people who are opting out of the test, just to kind of keep you involved in the content area. And then next year when you go to college, if you're in a statistics class, you'll know what a hypothesis test is. That would be my goal, and you would be able to roll from there. Okay, that's all the background stuff. Now let's talk about what we did last time. And I want to refer once again to page 456, 457, and 458. And I changed the content area from, I don't know what they were doing here, something about males and female births, I believe, something like that. But that doesn't matter because we are doing coronavirus, the thing that's most important to every human being on this earth right now is the whole idea of who's got it and can they be helped. And but today specifically, we're looking at testing and who tests positive. All right, because that's been a big issue. How do we identify who has it and who does not have it? So this is all made up, of course. But let's say we did a national poll This is from last time. Remember, I started with 5% last time. Then I gave you a problem to do 6%. And guess what? I think we'll answer last time's problem, but you won't know that until you get to this video. Hopefully, you won't look at this one first. But anyway, we'll go over that. So I'm saying the conventional wisdom, as far as we know, the proportion of people who are testing positive for the coronavirus is 6%. That's a made-up number once again. Then so once again, I want to stress to you that the HO, the null hypothesis, is always equal to something, equal, all right? Then the alternative, which says if we can prove that is not true, what is true, can either be less than, greater than, or not equal to. We're going to go with greater than or less than. There are very few in the book that did not equal to, but that would be on either side. We're going to go greater than or less than. And we said, because we're concerned about the coronavirus, we said greater than. We're going to go with greater than 6%. Then we need some data to prove whether we can reject this null hypothesis or not, okay? Remember, you can only reject it. You don't accept it. Unless we've heard something different. All right, back to your book, page 457. After the two hypotheses, you have to check those assumptions and conditions. If they don't check out, then you can't really do the test. So in the book, most of the time they check out, but we're going to assume the data is independent. Each sample is independent, that it was collected randomly, that the 1,000 is less than 10%. Obviously, 1,000 is less than 10% of all the people in the United States. So that easily checks out. And then the success failure, we didn't do that last time, but why don't we just check out? N times P, 0.06 times 1,000 is 60, which is well over 10. So if that's 6%, obviously 94 will be, but we'll check it out. 94 times 1,000 is 940. So they both check out. So the success failure condition checks out. So we're moving on to our mechanics, and we're going to look at a one proportion Z test. One proportion Z test. And the formula, this is an important one once again, is P hat, which is our sample, minus P null, which is the 6%, divided by that magical square root of PQ over N, which is the standard error, which is the same thing as our standard deviation, the measure of variation. Okay, so that's our formula. So we come over here and we do 6 P hat first. So we're going to do 6.5. So 0.065 minus 0.06 divided by, and let's do that square root of PQ over N. So that would be square root percent divided by 1,000. Let's see what we got for a standard error. So square root 0.06 times 0.94 divided by 1,000 gives us a standard error of 0.007. Okay, so we got to go out at least 3. At least 3. We'll go for 3. Well, if we're going out 3, it is 7.5. So let's even do this. Let's go 0.008. And now we could come up with, remember, this is z is equal to this. So we're going to do 0.065 minus 0.06. And I get 0.625 for z-score. Okay? Let me double check that. 0.0005 on the top, that is right, and 0.08. Okay, one more time. You know, we can check this in a second anyway, because I'm going to show you how to do it with the calculator. 0.005 divided by 0.008. Yes. So that's one of our z-scores. Z is equal to 0.625. What's the other one? Remember? Go back up to the alternative hypothesis. Greater than would be 99, wouldn't it? 99. Yep. So we are going to normal CDF. Remember, if you want a probability dealing with z-scores, and you get 0.62599. And I get 26.5 or 0.625 equals 0.625. What we're looking at is the question you should be asking yourself is this sample unusual? If it is really weird, then we're going to say something is wrong with that null hypothesis. But if it is not unusual, then we're going to fail to reject. Now, in this problem here, we came up with 0.265. You might say, well, what is unusual? Well, if you are not given anything else, the unusual guide is 5%. It is called the critical value or the alpha level, 5%. So remember our rhyme from last time, and it is this. When P is low, reject HO. P is low, reject HO. Well, is P low? Is it below 5%? Answer, no. So you should say, no, we're going to. This is what you say about this. If, I'm going to say this very slowly, but I don't have room on my board to write it, so I'm going to have you listen. If the null hypothesis was true, which is 6%, if it was true, then the sample, 6.5%, 26.5% of the time. Because 26.5% is not unusual at all, it's way above 5%, we are going to fail to reject the null hypothesis. That is precisely what we should say. Okay? Now, let's check this with a calculator, okay? This is all year long, you've known this is the good thing about the curriculum is you can check what's going on. Our new favorite key, remember, is the stat over to tests. Stat tests, and we go down to, we want, it doesn't, we did a one proportion Z interval. For the intervals, we want a one proportion Z test. Aha, number 5, option 5, one proportion Z test. Then it says, what is the null hypothesis? 0.06. What was our Success, that's what X is success. You might say, I don't see any success here. Well, you got to do a little math for that. You're going to go 0.065 times, and you can do it right on the line there with the X, times 1,000, and you get 65. Okay? And then you're going to put 65 out of 1,000. That's N. And we want greater than. And then you go down to calculate. And boy, do I hope this is 26.5%. It is 25.2%. You might say, wow, that's not exactly right, Mr. Child. I hope you don't think I did it wrong, because I didn't. This is rounding right here. Rounding. We rounded on this. And that's why we're not exactly at 26.5. But 25.2 is close enough to know it is well above the 5%, and we failed to reject. I love it. Everything went well. Let's do this. Let's change the numbers around. And I like this coronavirus problem. Talk about cutting edge and real life drama here. Let us change the p-value to 7. Let us change the sample to 0.095, 9.5%. And let us, just for the fun of it, to keep the numbers all a little bit different, keep us on our toes, let us change to, I don't want to change this a lot because I don't want this number to be really, really small. So let us just say 1,200. Or not, actually, yeah, we'll go with 1,200. Okay, so we changed the numbers all down a little, and I would like you to have just to mimic what I just did. As far as we know, 7% coronavirus. Is it greater? We want to know based on our sample. The sample says 9.5%. We sampled 1,200 people, and then you work through and use your calculator to check it and make sure you're right too. But if you could do that, that would be excellent. We kind of built on what we did last time. And if you can, write down the final statement when I said, if the null was true with the other one, the sample would occur whatever the p-value was, 26.5. That is an unusual. Therefore, we fail to reject. Okay. I was hoping, I don't want these lessons. First of all, I know you want to hear from me. Probably not too long, though. So we're keeping it under 20 minutes. Stay with me. We're having a good time. I'm looking for 3 contacts a week. And then on Mondays, I'm going to put the grades in. If you don't get them in, keep doing it. I'll change it. I'll put it in. We're just kind of doing it. And I'm going to keep this format. I really like it. I think it's good. We'll move on to other things. But for right now, we're doing confidence intervals. I appreciate your attention. Stay strong. A lot of us are getting edgy. This is unusual, but stay strong and things are going to get better. Thank you.